All right, hello everyone. Welcome to the second part of the video for section 1.4. And I know this particular GIF here may not apply to all of you because maybe some of you are old enough that your parents will not talk to you about your math grade. But I thought this one would resonate with most of us, or maybe if it was something like when you hear anybody mention your math grade, maybe that would then apply. Okay, anyways, it's again supposed to be meant to joke. Hopefully none of you actually feel this way about your math grade. All right, so we're continuing on with our study of function composition. And we've already looked at function composition with regards to both tables and graphs. So now let's look at function composition using formulas. And even though now we're using formulas instead of graphs or tables, this is still done the same way. So if we're going to do this first one up here, well, first of all, actually, I should say, notice we have two functions here. So f of p is given by the formula 2p minus p squared. G of y is given by the formula square root of y. So when we go to evaluate the first part there, f of -1. Well, just like before, we're going to start on the inside, which tells us to find f of -1. Which in this case, because we're using formulas, how are we going to do that? Right, we need to plug that -1 in for the variable there. So we're going to do f of -1. Here, the -1 is taking the place of the p. So that means we need to replace p with -1 everywhere else. So we have 2 times -1 minus -1 squared. Use our order of operations here, multiply 2 times -1, which is -2, minus, remember here we need to square before we deal with the minus. So -1 squared, -1 times -1 gives us a +1, so let's be -1. So -2 minus 1 gives us -3. So that's what f of -1 is. So that now can take the place of the f of -1 here. So this will become, instead of f of -1, but become f of -3. And to evaluate that, we repeat the process again, but this time plug in -3 in for p. So we would do f of -3 equals 2 times -3 minus -3 squared. 2 times -3 is -6, minus -3 squared is 9, so we end up with -15 here. Okay, so in this case, f of -1 is -15. Cool, let's look at the next one. So now, we are asked to find f of g of y, and what is the oh crap, what are we going to do moment in this one? Well, maybe because notice in here now they have not given us a number, but they have left it as a variable. Crap, that probably means we can't do this problem then, right? No, we can still do it. Okay, so first of all, notice on the inside there, the inside function is g, and it says g of y, which notice that's the same as what is up here, right? So they didn't actually substitute anything in for the variable. Notice also for g of y, we have a formula that it's equal to, right? Which is square root of y. So because of that, what we can do in this is actually replace g of y with that formula. So instead of having f of g of y, this will now become f of square root of y, because that's what g of y is equal to. Okay, again, that's because this here is the same as this, which is the same as this. And notice now that f of y is in the place of the p in the function f. So that means that to do f of square root of y, we plug in square root of y everywhere we see p. So this will become 2 times square root of y minus square root of y squared, which, again, because this is all variables, there's a whole lot we can do. we can rewrite 2 times square root of y as 2 root y minus, we do square root of y squared. Does that simplify? Well, let's think about this. If we had square root of 9 squared, well, if I'm going to follow order operations, I would do the inside first, which square root of 9 is 3, so this becomes 3 squared, but then 3 squared just becomes 9. And notice what I started with in the root is what I got here at the end. That's interesting. Let's see what happens if I do square root of 4 squared. Well, square root of 4 is 2, so it'll be 2 squared, which comes out to be just 4. Hey, same thing happened again. What was under the root is what I got at the end. So what is that telling us that a square root and a square do to each other? Right, looks like they cancel each other out, right? Here they kind of cancel out, square root and the squared, so we just end up with 4. Similar thing here, the square root and the square cancel out, and we just end up with a 9. So a similar thing happens when we have square root of y squared. That can be simplified to just y. Okay, so f of g of y just becomes 2 root y minus y. All right, and then for the last one, g of f of p, again, just as before, they didn't plug in anything for p, it's just left as f of p, but notice that's what we have up here. So what we can do there is just substitute that in to the function g, so this will be g of, and now instead of f of p, it'll be 2p minus p squared, which now means take that's in the place of y, so it needs to take the place of y and the rest of the formula in g. So this will become the square root of, instead of y, it'll be 2p minus p squared. In this case, that's all we can do. We'll leave it just like that. Okay. In case you're wondering why we don't cancel out the squared and the square root there, that's because this p squared is being subtracted with something. If it was just square root of p squared, we could cancel those out, but not because it's being subtracted, or we can't do it in this case because it's being subtracted with something else. Okay. All right, cruising right along. Let's do a little bit more with function composition using formulas. So in this problem, we're actually given what a composition is equal to. So we're told, in this case, that f of g of x, so 2 functions were composed, gave us 4 times the cubed root of x squared plus 5 minus 2. And what they want us to do is figure out what the formulas could be, the possible functions could be, for f of x and g of x. Well, let's think about a couple of things here. Number one, notice that g of x is the inside function, which means that it is the one that needs to have been plugged into another one to get this composition. And so what we might want to do to identify what g of x is to look for functions inside of other functions here. And one that I notice is I see this x squared plus 5 is inside of that cubed root function. So that tells me that it's possible that g of x could be x squared plus 5, which would then make the function f of x 4 times the cubed root. And because x squared plus 5 got plugged in there, that was actually in the place of an x. And then we have the minus 2. Does this work? Well, let's double check. If we do f of g of x with these two things, we'll notice g of x here we have the same as x squared plus 5. So this would be f of x squared plus 5. Which means put x squared plus 5 in for the variable in the function f. So that would give us, and I'm going to have to go over here, 4 times the cubed root of x squared plus 5 minus 2, which is in fact what we started with, right? So this up here. So that tells us that these two were good choices for what f and g could be. Okay. Now the next question would be, are those the only possibilities for what f and g could be? Could they be anything else? Well, let's try this on for size. What if I chose g of x to be I'm going to make g of x equal to cubed root of x squared plus 5. And then f, I'm going to make 4x minus 2. If I do f of g of x here, does that still work? Well, let's find out. So in this case now, g of x is cubed root of x squared plus 5. So this becomes f of cubed root of x squared plus 5. Can then take the cubed root of x plus 5 here, plug that in for the value of x here. So when we do that, we're going to get 4 times cubed root of x squared plus 5 minus 2, which notice again is exactly what we started with up above, right? So this one also works, or this pair also works. Okay? So what that tells us then is in this case there were multiple correct answers. There was no one specific answer that was better or more correct than another one. Okay? Alrighty. Moving on to our last slide for this section then. So looking at domain and ranges using function composition. So we're going to do a few things here. So first of all, notice we've been given two different functions. So m of x is 1 over the square root of x. H of x is x squared minus 4. What we're asked to do first is to state the domains for each of those. Now, I'm not going to go into a whole lot of depth on that in this moment because we did that in section 1.2. But I do want us to note that for the function m of x, it's 1 over square root of x. There's a couple of different restrictions we have to keep in mind there. Number one, that we have something in the denominator, so the denominator can't be 0, which means we can't have x equals 0. And also there's a square root in the denominator, which means we can't have any negative numbers under the root, so x can't be anything negative. So it looks like in that case our domain would have to be 0 to positive infinity. So all numbers bigger than 0 because of the root. And also we can't have 0 because then we would have square root of 0 on the bottom, which would make us divide by 0. All right, what about the function h? We have x squared minus 4. Are there any restrictions we have to worry about there? Well, in this case, no, right? Because there's no fractions, so we don't have to worry about dividing by 0, and no roots, so we don't have to worry about taking the square root of negative numbers. So it looks like in this case, our domain would be all real numbers or negative infinity to positive infinity in interval notation. All right? Cool. Now for the last part, h of m of x. So now they want us to, first of all, find a composition of functions. And notice in this case, m is the inside function. So that's the one that needs to get plugged into the function h. So we can write this then as h of, instead of m of x, put what the formula is, which is 1 over square root of x. Okay, and now that 1 over square root of x is going to get plugged in for x in the formula for h. So it's become 1 over square root of x squared minus 4. If you remember, when you square a fraction, so if you have something like 1 over square root of x squared, one way to deal with that is you can distribute the squared to both the numerator and the denominator. So this will become 1 squared over square root of x squared. 1 squared is 1, square root of x squared. Just talked about this becomes 1 over x. So it looks like our composed function h of m of x becomes 1 over x minus 4. And then to find the domain here, well, it might be tempting to say the domain, the only thing we have to worry about is this part right here, which is 1 over x. And we know the only restriction we have to think about there is that x cannot be 0, right? Because we can't divide by 0. However, because this is a composition of functions, we also have to consider where we started. So back up here. When before that became 1 over x, it was actually 1 over square root of x squared. And in that case, we are not allowed to have negative numbers in there as well. So x can't be 0, but it also can't be negative numbers because of the square root. So in this case, our domain for this function actually ends up being 0 to infinity. And again, the reason for that is because even though negative numbers are allowed in the domain of the simplified function, we had to keep in mind the function we started with. Okay? All right, that's all I got for right now. Thank you for watching.